My name's Bil Herd. I'm a recovering Commodore engineer, I like to say. After today, maybe you'll know why. Stop playing with my slides. So you're ruining my mojo here. So no, I talk about Commodore as a Greek tragedy in 3 acts. And I'm from Act 2. I'm from right at the end of Jack Trammell and the +4, what we call the TED series. Jeff, could I get a thing of water from you? Thank you. To the C-128 and the dawn of the Amiga. So I call the Amiga Act 3. So how many remember Commodore? Do you even know what this logo is? Do you actually remember it or you just hear it? So I used to tell people, yeah, I work for Commodore. They'd be like, oh, that's so cool. Then it became, well, your parents might have had a Commodore. And then it was like, well, there might be a Commodore upstairs in your garage, somewhere. And now, no, nobody knows. And I am disheartened when I see a show about the 1980s, and they'll show the Apple, right? I'm like, what about the Commodore 64? Guinness Book of World Records, We were the highest selling home computer, not personal computer, home computer in the market. So it is sad to me that we don't see that anymore. Now, this is something that used to happen anytime we left a logo laying around. Somebody inevitably would do this to it. And I'm going to go quick here today. So we call this chicken lips, but inevitably, and somebody said once, he couldn't get this next image out of his head once we'd done it. This is why you don't know about Commodore, right? We're dead. We're gone. So Apple it did invent the world, if you ask them. My humble apologies to Apple, but yeah, we're gone. So my story starts, and let's see, hang on a second. If I got one. So when I was in basic training, I remember one of my drill instructors held up a Claymore mine and he goes, any questions? Well, I just came out with a book, and so I almost want to just go, okay, have you read it? Any questions? Because everything that's in here, there's one. Everything I'm going to talk about is in here. So there's no new stories, unfortunately, in 35 years. I know you all have heard this before. So my apologies that I'm going to go over stories that you've already heard. But my story is one about a young man that walked into Commodore, actually MOS technology, in the 1980s. And I got my job sheerly out of luck, pure luck. I was having a hard time with my boss. And I got told about a job interview that was possible that night. So I threw my suit in my van. My van broke down. I got there late, was not in my suit. And I walk into the first guy. His name was Frank Hughes. And I'm like, oh, yeah, I was very excited about technology. And I think I was too excited. It's like, oh, no, I'm a no. I've alienated this guy. So I walk into the next guy named, I've forgotten his name, Bob Russell. And we're talking, and finally he goes, well, if I load X immediate 05, and I muttered the opcode under my breath, I'm like 8205. And he looks at me. He goes, store absolute, and I'm like 8D, I'm parroting it back to him. And I remember his body language changed, and it was like, that was the moment I got hired at not hired, but that was the moment I got my break at Commodore. So Bob says, come on down to the plant tomorrow, and that's exactly what I did. I went down to the plant thinking I'm just going to see a chip fab. Chip fabs were like, oh my gosh, this is the holy grail of places for somebody that had learned and studied electronics. And I want to tell you, the 6502 was the gateway drug for me. I lived and breathed the 6502. It was the first processor I had ever worked with, and that's how I knew the opcodes. I actually used to read them where you do the byte swap to the point where whenever I would try and dial a telephone number, I would accidentally byte swap the numbers and dial the wrong phone number. So, but it helped me get my job, right? I knew these opcodes dead. So I get to the main plant. I'm walking around like a kid. Oh my God, this is so cool. And they say, wait here for Shiraz Shivshi. He'll be interviewing you. So I plop down in a nice looking chair. The next sound I hear is, excuse me, you are sitting in my chair. I'm sitting in the boss's chair. It was facing the wrong way. He liked to look out on the golf course too that was next to the building. And it's like, oh my God, I just blew it again. And then he goes, where's your resume? And I'm like, I didn't bring it. I thought I was coming for just a tour of the plant. Well, at this point, the first guy who I thought was a no says, I have his resume. And he went and he got it, and he saved my job at that point, and then brought up a technical matter. And when I was talking with him about it, it was about a vibrating wire scale. And I said the vibration of the wire is proportional to the reference weight and everything. And Shiraz looks at me and goes, close, but it's the mass instead of weight. And he was absolutely right, but his body language changed a second, again, and I realized I had just been hired. And I also remember, leave a mistake in there that your boss can fix for you, right? So I remember watching the show about the guy that wrote the ET, wrote the ET program, and it showed him walking up to Atari the first day. Well, I remember my first day walking up to MOS. Is Bill Mention here? No, he'll be, but he knows this shot here. Bill used to work up in these corner offices here. That's where we put our chip guys too. So I remember walking up to this plant, and it was like my first day. And I made the mistake, I didn't know any better. We had polluted the groundwater. I'm saying we already. MOS had polluted the groundwater and had to set up a sprinkler in the back to spray the water into the air. Well, I parked over by it. And so when I come out from my first day of working at MOS, I got this sticky scum stuck to my car. Not only that, I parked under a tree, because shade's good. And these leaves are stuck to my windshield from this sticky mass. So it was like quite the learning experience working for MOS, but I still, when I look at that, I still remember the day I walked up to MOS. So this is the 1980s, right? Here's something you guys can't listen to live anymore. I remember hearing Pink Floyd live. I remember reading Hitchhiker's Guide to the Galaxy when there was only 2 books, right? And the answer 42 wasn't yet among us. And so it was an amazing time to be alive. It was the best time of my life to this day. Things looked a lot different back then. This is what a beer bottle looked like. That's what I looked like holding a beer bottle. So yeah, I was a young rapscallion upstart. Basically I have a high school diploma, but I still owe them an English credit in theory. And I'd never even seen a college at this point. So when I first get there, we get told about this program, this computer called a TED. It meant text display. And it was supposed to be let's see if we have it here. I want to skip some things. There it is. Shiraz called me in his office and said, this is our next computer. This is the computer we want to put a nail in the coffin to. This is our target. We want to kill the Sinclair Spectrum. And so this TED computer system was supposed to be a business machine. If you wanted to play games, get a Commodore 64. It's the best game machine out there. It's got sprites, it's got sound. So why do another kind of computer? Well, it's another usage. It's a text display. It's for business, and it was meant to cost $49. So what happened my first week while I was there was I was hired as a technician, it turns out. I didn't know that until I read Brian Bagnall's book. And then my first week, they sat me down in a chair and said, you'll be writing code for Benny Pruden here for disk drives. Well, okay, I'm still in Commodore. I'm not a hardware engineer, but I'm still in Commodore. So I go wandering off, though, my first week, and I walk in the hardware lab, and there's it's a wire wrap monstrosity. And I'm talking to him, I'm like, well, wait a minute, are you sharing the bus? He goes, what? You know about that? I said, yeah, I'm doing a project at home. We're all passionate about electronics, right? So I'm doing a project at home where I'm sharing the bus, which means that video has 1/2 of the time to get to the screen, to the memory, and the processor gets the other half of the time. That's what made the 64 so beautiful, was this ability to go fast while writing graphics, let alone sprites and these movable object blocks on the screen. It was this bus splitting technology that did it for us. Well, I knew all about it, and by the end of the first week, Shiraz called me in his office and said, you're now in charge of TED. By in charge, I mean I was the lead engineer. I did not design it. It was a single chip system designed literally by the chip guys, but I became the lead engineer on it. And here's what it was supposed to be. It was supposed to be a $49 business machine. Looks a lot like a Sinclair, doesn't it? 121 colors. It was 128 colors, but 8 shades of black is still black. So we have 121 colors. You can see the column there on the left. And it had sound, right? But it wasn't a SID chip. It wasn't supposed to be a SID chip. It's supposed to just boop, bark, do little beeps. And if I had more time, I'd tell you about the memos that we wrote when we tried to write white noise. You know, came out, dong, 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 dong. It sounded like a choo-choo train, right? But we were learning, right? We were trying to make the equivalent of a single chip system. Matter of fact, I have one here. This case was designed by a guy named Ira Vilinsky, who's since passed. Every bit of usable space is taken up by a connector port or something. And when you open it, that was the single chip. This is the Raspberry Pi of the 1980s, in my opinion. It was beautiful. It was a work of art. And there's some techniques in here. This was what we did was we did the initial design, shipped it to Japan, and Japan relayed it out because that was the mentality from the C64 days. And in doing so, I learned some dirty techniques for mass production that came from this. So there's things in here I would show you that, but what I learned to do was put aside, I learned to fight dirty is probably the best way to say it. Because we had to make stuff work in millions, but it had to be cheap. $49, well, the TED chip cost me $1, right? Do the addition, the TED chip being the main chip in the whole system, do the addition, and you'll find that, you know, for $49, our cost had to be a third of that. So this was the Raspberry Pi of the 1980s. So it was beautiful. They had developed a whole family to go with the TED. This wasn't just a computer laying out there. There was 2 printers. There was a monitor called the 1801. We had the 116 I just showed you, the 264, which had 64K of memory, and then we had the V364. V meant voice. We had absconded with the people from the TI Speak and Spell. Yes, the biggest piece of technology of the day as far as home users were concerned. I mean, it was in the movie E.T., right? The Speak and Spell. We had them working for us, and we made a talking version of the TED back in the 80s. They had an application called Magic Desk, and it was a talking Magic Desk. So we had a desktop motif. It died on the vine. Y'all probably haven't heard of it, but if, I don't want to slam Apple, but I'll say they didn't invent the, you know, Park invented it, but we had a desktop motif as well, but ours talked. So this to us was like, this is really cool. This is what a TED chip looked like for the day. This was magic. This is the thing that I go on about is there were other computer companies out there. A lot of them just used our chips. We made chips. We had the magicians. We had people like Bill Mensch had previously been there. We had the Al Sharpentiers of the world. We had the wizards, you know, the legacy of Chuck Peddle. So this chip, with the ability to make a single chip system, was ours and ours alone, it felt like. Now, TI, you know, there are some people that did make other chips, don't get me wrong. But this is what this stuff looks like in real life. And if you look at it, and if it looks like a bunch of gobbledygook, it pretty much is a bunch of gobbledygook. It's just it happens to work. So my second week there, I'm in the chip lab. I stopped in. The place was a candy store. I was walking around everywhere like a kid at a carnival. And there was a problem with the TED chip. I remember, I'm sitting there, there's 3 guys around a microscope and they're probing. Did you guys probe, Bill? You did with the whiskers and the probing? So they're probing this chip that again looks like gobbledygook, right? And the guy says, all right, we're in PAL mode. Turn on the microscope light. He turns on the microscope light. He goes, we in NTSC mode? Good, turn off the microscope light. I stopped, I looked. Wait a minute, did you just use the photons from the microscope light to flip a register to put it in NTSC mode? And the guy goes, yeah. Mm-hmm. I'm like, oh, I am working in the best place in the world. This is it. I don't want to work anywhere else. What had happened was we had no electrical rule checks back then. We had design rule checks. So if a trace got too close to another trace, that'd get flagged. But if the trace cut cleanly across these traces, that's a great short. That's a clean short. Go ahead with it. Well, that address line short meant we couldn't talk to the register to put it into NTSC mode, and they had to use the microscope light. So, and the whole point of that was you try to debug as much of the chip as you could before you ran it again. It cost between $500,000 and $250,000 to do a run of chips, a lot, we called it. So they would debug as much as they absolutely could between revs of the chip. Long about my third week there, Schra sends me down to the production engineers at MOS. He says, go make a deal. I'm like, for what? Figure it out. All right, I go down. Well, they had made some chips wrong. And I'm sitting there, I had taught myself a way to do the timing calculations and had already reviewed it. I mean, I'm working in the best place in the world, so I'm digging into all the information I can. So I go down with my little HP calculator. These things were just horrible. You had to twist this for the digits to light up correctly, and you had to make sure the answer didn't change when you were doing it. And they're there like, well, we have this much for time res pre-charge or this one. And I'm madly typing away on my calculator, and something bad happened. My calculator gave up the ghost. The battery was only good for 8 minutes back then. I'm a young kid, right? So I look up, and I'm looking at them, and the way they're watching me, I'm like, well, wait a minute, something's going on I don't know about. So I made up some numbers like I'm still typing, and I could see them kind of relax. And I realized they were playing poker, right? And they were playing poker with me, and I didn't know it yet. So I started watching their body language, and I'm still typing on a calculator, it's dead. They just don't know it's dead yet. And so I would go, we can make this time this, and they'd get upset, or I could relax. And finally I said, so I realized where the issue was. I said, okay, guys, what's the problem? Tell me and I will help you fix it. And they did. They said, we blew this spec, just outright blew it. And back then at MOS, if you messed up the recipe, some people could get in trouble. It was a lot of money, and there was accountability. So I found out a way that day. I said, well, if you give me this, can you give me this other number? They said, yeah, we can. I said, that's fine. I'll sign off with this timing violation if you give me this other one. And the moral of the story was, let's work together and get this, let's fix this. And that relationship stayed the same good that way for the rest of my time at Commodore/MOS. By the way, I'm wearing an MOS shirt. I started at the building Bill Mensch helped found at the company. We started at MOS Technology in Norristown, so my paycheck said MOS on it, which later became Commodore. So we get to, so the TED family, specifically this one, had a mandate. Somebody had gone up the mountain, met with Jack Trammell, and came down and said, there shall be only 9 chips in it. I'm like, well, that's fine. Excuse me, that's fine, but your reset circuit sucks, right? It just did. It wasn't going to work, let alone in millions. And I knew this from the work I'd been doing. And I said, so I'm going to put a reset circuit in here. And they lined up to like congratulate me, shake my hand on my last day at Commodore. It's been nice knowing you. You're out of here, right? But I put in the reset circuit, I made a justification, and lo and behold, I didn't get fired. So that was kind of that moment where I realized I can do this, right? I know what I'm doing, and I can do this. So meanwhile, during this time, the C64, best home computer ever, I mentioned that, had some issues, right? And it's not the fault of the VIC chip even though it was the VIC chip that was most known for these issues. The fault was we didn't have enough clock edges that we could tell time exactly when we needed to. We had good clocks we knew, and clocks in the middle we had to fudge. Well, that resulted in sparkle. Has anybody seen a Commodore 64 sparkle? You don't see it as much these days. It used to sparkle a lot. There was these jail bars, they call them, and stuff. And so one of the things they did was they developed a tiger team to address these problems. And one of the ways we got rid of the sparkle, you know, you've seen that Commodore 64 screen, that beautiful screen, the light blue and the dark blue. What they did was they changed on all the cells that were just dark blue, they changed the foreground color and the background color to be the same color. So it's still sparkling, you just can't see it. It's sparkling between foreground and background. And then wherever there's a character, then you would see the sparkles in there. So we had this DRAM timing issues. We were throwing away DRAMs by the truckload, and we ended up suing Micron Technologies, who ended up suing us. And as the engineer that looked into this for the C64, I'll tell you the answer was we were both culpable. It was as much a problem with the way we used the DRAMs as the DRAMs themselves. They had issues also. During this time, there were no engineers allowed in production. I got escorted out twice out of engineering. Out of production. And strangely enough, the way that got fixed was I drank beer with the head of production one day. They hung out at a different bar than we did, and I hung out at all bars. So I told him, I said, we can help. I mean, it's the same speech I had with the chip guys, right? We can help if you'll let us. And they were hiding some things. They were doing things like they were, let's see if I have it on here. They were putting capacitors. To get it to pass the test, they were soldering capacitors on the DRAM control signals. Oh my gosh, this is a no-no, right? It looks like it works. Well, it would pass the test better, but it would crash the computer faster. And that was one of the reasons they didn't want us down there. They didn't want us to know about some of the stuff that they were doing. We also had, anybody here know what the PLA is in a C64? Yeah, everybody. Why do we know about the PLA in the Commodore 64? They die. It used to get the purple creeping crud. We had bad passivation. I thought it was a mechanical issue. I thought it was the way it flowed over the traces and whatnot. Bill, do you know what was wrong with our passivation? Have you ever heard? Supposedly there was too much boron in the silicon nitride passivation, and it was causing an issue, and you could see it. These chips only lasted 6 months. By the way, the PLA that's in the Commodore 64, say it, but we stole it. That originally had been A2S100s by Signetics, and when you walked in our chip lab, what you saw was a row of Polaroid pictures of where we had decapped one of theirs, and we made our own design for it. So we had our own version of PLA, and it was that version of PLA that was having the issues. So back then, when we came out with the R8 VIC chip, it did things like went to a beryllium lead frame, which got the heat out quicker. Well, heat was the enemy. Heat made sparkle. These things were so valuable that if you left your Commodore 64 or even your lab unit sitting out, you'd come back from lunch and the chip, they'll swap it. They would take out your Rev 8 version and put in an R7. So one of the things I did was I ordered, turns out an engineer can order downstairs and receive tubes of chips. It's like a superpower. So I send downstairs, and I'm like, send me a tube of R8s. And I put them on a counter with the sign that said, need one, take one. Boom, it's gone. I put another tube there. Boom, it's gone, a little slower. And then finally, the third tube, I had saturated the market. So suddenly the theft stopped and life became better for us 64 owners. We shipped a bunch of units to the trailers, but they disappeared, and I won't talk about that here. So one of the things we did do for the TED series was we made alpha units. So the idea was, you can't just release a computer. You got to have software on the day it's out. Why else would you buy a computer, right? If there's no software for it. Well, how do you get software there the day of release? Well, you have to do early releases to the people who write software. So we made what was called an alpha unit. And this thing's just hilarious to me. We had chips were buggy where we had diodes hanging off on them. And when, these aren't my pictures, but when I first saw these pictures, it was like there was my handwriting from when I was 24 years old. You know, it's like seeing this. Look at this chip. There's Scotch tape holding on the top of the case on it, right? What a great place to work, right? The wizards are downstairs. I called it the dragon. It's like being above a chip fab was like living above a dragon lair. You could hear it down there breathing and the heat and the fumes. We had an explosion one day. It's like it raced through a thing. So, as I mentioned, the beautiful case design. I don't have anybody have their 264 with them or plus 4. The same guy, Ira Walensky, designed that. Well, Ira designed the joystick. And remember, this isn't for games outright. If you want a game machine, get a Commodore 64. So, and these had these little DIN connectors on them. Everybody hated them, but they happened to fit the side of the back here where you couldn't have gotten a regular Atari connector. So people that got pissed at that didn't realize that what we were up against. There was no room for the Atari joystick connectors. So along with this design, we get a new one of these, and Ira's showing it. He's very proud of it, and rightly so. It was beautiful looking joystick. I looked at it and said, they're going to break it. He's like, what? I said, kid's going to break this thing, man. No, it isn't. It's designed. Oh, okay. Well, look at that end of the table now. You all just stop paying attention to me. And I took the joystick and I took it below the edge of the table, and I leaned in it real hard. Now, I'll admit it took a lot more effort than I thought it would to break it, but suddenly you hear snap! And me pushing the joystick out in the middle of the table going, sorry, didn't mean to do it. But I'd made my point with a $40,000 joystick that it could be broken. This is what was called a soft tool, right? So Ira got mad at me. Ira was one of my teachers of Japanese, and he was from our Tokyo office. So from that day on, I had to watch the words Ira taught me, because he taught me some bad Japanese without me knowing it was bad Japanese. So, as I said, I didn't design the TED, but I was the lead engineer on it. So I'm slowly walking. I'm walking around with the schematic under my arm, right? I'm the guy. But mentally, I didn't own it yet, right? I was still batting for the guy who had come before me is how I felt. One day, then, we get our computers. We plugged in a joystick, as it turns out. And when you got the joystick near the monitor, you got these black dots on the screen. I went, that's data line interference. That's a control, that's not even a control line, that's a vital thinking line inside the computer is being corrupted by the joystick. I'm like, well, if that's true, then putting it up to the monitor real hard should, yep, crashed the computer. I look, and sure enough, the data line, this had been a good idea to the chip guys, no offense intended. This had been a good idea, was to use the data lines to drag it straight out to the keyboard, to this part. The data lines of the microprocessor went to here. This is a bad idea. It radiates this, and the data lines aren't meant to make the trip down this connector. This connector even has foil on it because it's a prototype to make it better. And then the worst thing was one of the data lines went out the joystick port for the fire button. So when you put the joystick near the monitor, the high voltage emanating out of the monitor would pollute D0. I looked at the schematic and I realized what it was. I mean, I had the schematic with me. I open it, look at it, and I start laughing. My boss is not amused. I look, I said, data line, going out joystick port. I missed it. And his response was, fix it or you're fired. I'm like, okay, I like a challenge. I'll fix it. Fix you. About an hour later, the boss walks in. I was afraid of that. The boss walks in, and I'm playing a video game. I think it was Warlink, whatever that one was. And he looks at me and he is pissed that I told you to fix it. I point to the monitor, which is now sitting with its case off. And he missed it. He said, what's going on here? I thought you were going to fix this. Well, I point again. He still missed. I had a 15-foot cord put on the joystick port. I'd already fixed the joystick issue. And to prove it, I'd put a 15-foot cord on it and wrapped it around the yoke of the monitor. I'm sitting here playing a video game to a cord that goes behind the monitor, wraps through the high voltage, comes back out, and that's proof I fixed it, right? He still was not amused. But that was our proof that we fixed it. So that started this where we fixed everything in a day. We didn't have time to let a problem grow to be a bigger problem by the next day. So the time to fix on that was a day, literally a couple hours. And we got it. The beauty of it was I was able to look at my MOS catalog and pick the 8529 chip. And it turned out to be, I hated using chips that weren't made by Commodore, made by MOS, because I couldn't control the production on those. But if we needed that 8529 for TEDs, you better believe they're going to be on the schedule to be made. So it was a beautiful fix. The TED. Anybody here know who Dave Haney is? Yeah. So I hired Dave, and there's a whole story about that. I'm not going to tell it right now. But during this time, we hired Dave Haynie. TED had a ROM monitor in it, which made it a perfect pirating tool. I got a telex. Remember telexes? I got a telex saying, you now create, from one of the heads over at Commodore England, you've now created one of the perfect pirating tools for, pirating tools. I sent back a one-word telex that said, thank you. Thanks, THX. So during this time, we moved to Westchester. And I remember this because we found the golden 64. Anybody ever hear the golden 64, Commodore 64? What was it, Chris? The millionth sold. Millionth made, something like that, right? Well, the way they found the millionth was the guy had stood at this pile of Commodores and gone, it's here somewhere. Yeah, there it is. That's the 1,000,000th unit. Takes it and he spray paints it gold. So during the move, we found the 1,000,000th unit. We make CES. We get to CES show. Thanks to Chris for this picture, by the way. And this is Jack Trammell's second to last day. That's him holding, I guarantee you my fingerprints are all over those two machines he's holding. We get back from the show to find out that Jack Trammell's gone, and we're without our leader. And we worked for Jack Trammell. He was our guy, we were his guys, right? There was a loyalty to him that I can't express even to this day. So it just saddened us to no end and worried us that he was no longer with us. Bad things started to happen then. Here was our product family with Jack. Then we started getting new variants. The 232 appeared. Then it became the +4. Then it became the C16. Anybody familiar with all these different models? So I have a C16. This is my FCC evaluation module, personal one. I learned to like this only about in the last 10 years. And it's because I received so many emails from people in Europe going, they dumped them over here. My school is full of C16s, PAL version, C16s. I learned to program on a C16. Thousands of us learned to program, and so I started to like it. I hated this thing when it first came out. I thought that's a bad waste of a Commodore 64 case, because that's all we did. We stuck it in a 64 case. The original one was even a single-sided PC board. I mean, we were trying to make it for like $12. And if you think I'm kidding, do the math. That's how you get to $49. So we start to see things go to heck in a handbasket without Jack Trammell around. During this time, I was working on a computer called the Commodore LCD. Turns out Commodore owned its own LCD glass plant called Eagle Pitcher. We were the only American glass manufacturers. Everything else was And this was how Commodore did stuff. We owned the capabilities. We made our own chips. We had our own LCD glass. And it was going to be evolutionary, right? Everything else up until that, C64 was evolutionary in my book. This was going to be the next one, the personal computer. So while I'm working on it, I had a guy working with me named Jeff Porter, and I handed it off to him. Let's show some more of it. This is cool. I almost brought mine with me. I have one of these. Hey, anybody here, have you heard of the LCD machine? Yeah, there's 3 of them. So this is one of them. So one day I'm in the lab, and Fred Bowen, who had done the kernel on the +4 series, he's sitting there with an engineer, and the engineer is complaining that the logic analyzer is not working right. And I'm working on the LCD machine. And the engineer just keeps complaining about the analyzer. It kept triple clocking. I knew what that was. I knew that if you shorted the outputs together, it would upset the clock and it'd think multiple cycles had passed. And finally, I couldn't stand it anymore. I turned around, I said, give me that. And I looked at his paper. He had photocopied it crooked, and a column of terms had gotten cut off. And I'm there, there's your problem. You've got output contention. It's upsetting your analyzer. Now, please shut up. Hand it back to him. And I remember Fred Bowen looking at me over his glasses. I turned away and I looked back. I'm like, what are you working on, Fred? I remember thinking that. So within the week, Fred and I get together, and I said, what are you working on? He's working on something called a D128. I forget what the D family was. It wasn't the business family. It was this weird family of products. I think there's a D256 out there or something like that. Anybody familiar with the D family? Anybody familiar with the B family? You've seen those. If you saw Wonder Woman 84, there was a B family in there. Well, the D128 worked off of 6509. It did this real funky banking thing to get to memory, which meant it's kind of like holding onto your ankle, hopping up and down to just write a byte to this thing. And as opposed to what we call where we map it. We just go, oh, here's all the memory for you. Now, here's a window into it, and you have to do all these things to get to it. It was based on the VIC-2, but it wasn't Commodore 64 compatible. It was just using the VIC-2 chip. So Commodore was about to come out with a new computer that wasn't compatible with anything, right? So Freddie and I get to talking. We said, well, let's make it 6502 based, 6510. Let's put in a memory management unit and window that memory in huge banks, right? The 6502 is still limited to 64K, so the biggest bank is 64K, but I can go 64K, 64K, and give you full access. Or mix and match, or I could make it when you wrote to this one, it ended up in this. We had all these tricks in there. We said, well, let's add a 80 column. That sounds cool. Imagine working at a place where the engineer gets to say, hey, let's add 80 column. That's cool, right? So we haven't told management this yet, by the way. And then we said, let's make it C64 compatible. With that, we added a SID. Need it for the C64, that wonderful sound chip that's in the C64. We had learned a trick during the TED, which was we could double the clock speed, especially in 80 column mode. Suddenly, I mean, you don't know how hard it is to make something go twice as fast. This was the easiest doubling we ever had in my part of the industry. And we wanted a built-in floppy version. It's called the C128D, if you've ever seen it. And I wanted a reset switch. Yes, Bil Herd is known for being a reset, very anal about reset circuits. We didn't have a reset on the Commodore 64, and we wanted one on the 128. We had, so to set the stage, it's 5 months before CES. We finally told management, hey, we've got this concept called a C128. By the way, that's its name, not open for debate. We've already named it. And we'll have it ready in time for CES. Now, this was important. Jack Trammell's gone. We don't have that strategic direction. The Amiga is in the wings, but that's all it is. It's in the wings. And we're going, we need something to show at CES show. So what happened is this was a design that came off of a young engineer's desk. I initially did it in graph paper on 0.1-inch graph. 30 minutes? I'm good. On graph paper, and said we would have 5 custom chips done in 5 months in time for CES show. Here's the chips, a lot of them. We went straight to PCBs. This is an early prototype. Look at this mess. That worked. To do the chips, don't watch if you're a collector. I mistreat my stuff really badly because I saw it work 30 years ago and I don't need to know it still works. This is what we did to the VIC chip to make it the Commodore the VIC chip for the C128. These plug directly into this board. So instead of an MMU, which didn't exist yet, we would plug this in as a chip emulator. This plugged directly into the board. That was the PLA. Come here, you. I can hear the pins breaking off. Does that make you nervous when I do that? Yeah, look at the static, right? It worked 35 years ago. That's all I need to know. I don't need to work. And this was the MMU, the memory management unit. Now, it was almost the first memory management unit in a home computer, except that I didn't include a supervisor mode. So, and we wouldn't have needed one. There wasn't a supervisor mode in the processor. But the main thing was, we said we can get this done. So to be done on time, we have 5 months to get this ready for CES show. That means that we've got to sell the units. The units have to be ready to ship in January. CES is January 6th this year. And we had to have the units ready to ship February, January going into February, which meant that we had to apply for FCC in December before the CES show. So before we're even done, we've already told the FCC what it is we're making. So one of the things I did was I got with the guys. Back in the TED days, there had been this nauseous finger pointing where the chip guys blamed the programmers blamed the chip guys, and everybody hated the hardware people. So I sat them down and I had the talk. And this is with Dave Diorio, who went on to make sure every chip in the Commodore, except for the 80Com chip, every chip worked, and it worked well in 5 months' time. But I told him, I told the programmers, I said, you tell him, the chip guy, what you want, and he will do his hardest job to make that happen for you. He is the magician. He is the wizard. He will make it work for you. The downside of that is, as we get closer to the deadline, we're going to have to fix first the chip problems in software and then my hardware problems in software, because at the end of the day, the only thing we can do in the last couple weeks is rewrite code. So I told him, you get everything you want up front, but in exchange, you pay for it by writing patches to fix the hardware in the end game. And know that now, that you will be the guys that save the day. And they were good with that. So they got that out of the way. One of the things I wanted, a new culture, this sounds stupid, I wanted a fuse on it, on the Commodore, on the power supply. Anybody, you're familiar with the Commodore 64 power supplies? Yes, they get hot, right? They got that nice epoxy in there to hide all our sins, right? There's no fuse in that. It just gets hot or it gets hotter. So one day, this was a religious experience for me. We're talking about the 6502, and Mike Angelina, the head of the Calma unit, says, yeah, we got that here. I said, we got what? He said, we got the schematic. I said, you what? He said, yeah, it's here in this drawer. We went to the dirtiest, dustiest cabinet to the bottom drawer, and he pulled out the 6502 schematic. Now, this isn't it. This is a blue line, but this was the actual pencil one. Bill, I didn't know you guys wrote on papyrus back then, but this was parchment. It was a religious experience. They opened the door and the lights dimmed. There's chanting going on. There's incense somebody lit. I mean, it was like, oh, It was the 6502 schematic in the flesh, in pencil, right? So I'm going to add to the urban legend of the set overflow pin. We're sitting there looking at it, and on the pin, on the pad, it said CPS. Do you remember what CPS stood for by any chance? Benny Pruden starts laughing and goes, Chuck Pedal Special. We called it the Chuck Pedal Special pin, and yes, we did actually, I heard you on one of your talks, you said you didn't know if it's used. We actually used it in a disk drive. They did a branch of overflow clear in one of the disk drives instead of an NMI. So this was a religious experience for me. As I said, the 6502 was my gateway drug, into electronics. So I got to ask Chuck Pedal. Jerry Ellsworth and I did a video with him many years ago now. And we played a clip where we showed the Terminator code, right, which is obviously 6502 assembly code. And of course, Bender, the kill all humans robot, is run by a 6502. I'm like, Chuck, are you really an evil genius bent on the destruction of the world? And without batting an eye, Chuck's like, no, if you look at the number of medical units that are 6502 based and the number of units, he batted that right back at me about how many. So my answer was, so what you're saying is you've saved more lives than you've taken with the 6502. Or you say, yeah, something like that. So here I am, a disciple of the 6502. And sadly, one was made after me with my name in it because we made a mistake. We needed a 48-pin version of the chip because I needed all the ports that are in a C64, but I needed the sync pin brought out so our logic analyzers would work. So we said, hey, we had this brand new thing called a 48-pin package. We'll just drop it in that for just the purposes of doing our emulation. Well, we walked over to the photocopier with what's called a lead bond diagram. And instead of going 148, 247, doing like that, we went around the corner like this. And in short, the wires wouldn't reach unless somebody turned the die on the chip. So it ends up looking like a tie tack, and that's what we called this thing. The 6510 Herd was called the tie tack. But here it is. I'm honored to be in the presence of the mother of the 6502, as he likes to be known. And yet a version of those unfortunately got stamped with my name on it. That's a block diagram in the 128. It's complicated. That's the only reason that's there. If we thought it was I sit there and look at this at my age, right? I go, holy cow, how did we get that to work? Let alone in 5 months. So with 3.5 months to CES show, this is this board here. This is what it looked like. So if you're 3.5 months to the CES show and you've got dead chips, or dead bug chips, these are chips soldered to the bottom of the board. We got wire, we got power supply lines. How the heck is this going to be done on time? And the question for me was, what's scariest, this mess, or the fact that the lead engineer looks like this?
Nice shorts.
Nice shorts. It was the 80s. Holding a beer, by the way, Michelob. That's Dave Diorio, who's passed on since then, but he's the father of the chippedness of the C128. So meanwhile, we had a problem. We had a CPM cartridge for the Commodore 64, and it didn't work very well on Commodore 64, and it worked not at all on the 128. Of the two we had in the R&D lab, one failed, so failure of 50%. I thought I had a slide that showed why. So I was stuck with this problem of this CPM cartridge doesn't work, and it wants an amp and a half. That's a couple dollars, right? And that means I have to make the power supply. By the way, it's a switching supply. It won't just get warm and put out a lower voltage. It'll stop working. It will kick off if we pull an amp and a half too much out of it. So I had this problem. Do I make the supply be more expensive for one single cartridge that's not even going to work right, or I could put the Z80 on the main board? And that's what we did. This board doesn't have a Z80 on it. This is from the rev before that. So management leaves one day, comes back the next morning, and we had a Z80 board tacked to the system. Now, the problem I had putting it in, remember I fixed everything in one night. We did as a team. The only place we had Z80s was in our own Timex Sinclairs. I had started the habit of taking Timex Sinclairs and using them for a doorstop. Perfect doorstop, right? No offense, Sir Clive, Sir Irving. So we had to go around tearing open doorstops to get the Z80s out of them. So I came back, I had torn open a Sinclair with rather abundant force, and it had cut my knuckles. And I come back and I'm bleeding, right? But I've got a Z80. And somebody's like, what happened to you? I'm like, one fought back. We tried to, I'll just show this real briefly. We did have, the Z80 has a clock requirement that's very NMOS. It doesn't like NMOS, the process we used with the 6502. Z80 clock wants to bang all the way to 4.9. Well, an NMOS, as Bill will tell you, gets to 4 volts and then it kind of changes modes and it kind of takes its time to get the rest of the way there. And Dave tried to do, I'm sure he tried to do a voltage doubler to spike this, to do the word for, escapes me right now, bootstrap it. So he came back to me and said, it's not going to work. So I had to figure out a way to make this voltage slant to 4.9 volts. And what I did was a simple circuit here. The only thing I'll show you is I used a transistor. By the way, I'm into the point where I can't make big changes to the circuit because FCC would start all over again, the submission. But I used 12 volts to make this thing slam up to 5 volts. I'd never seen anybody do that before. I walked around everybody I knew, people I liked, people I didn't like, people whose opinions I respected, and people whose opinions I didn't. And I asked them all, what's wrong with this circuit? Can I build a million of these? Can I build of these? And nobody could think of a reason why we couldn't. So we ended up using a 12-volt power assist, which meant if the 9 volts went out, the Z80 went out, which meant the whole thing went out, it stopped working. But with this 12-volt power assist, it's actually a circuit that, for all practical purposes, we invented for the C128. I've never seen it again. I'm not sure I want to. But we weren't going to be stopped by anything. We were going to get done. So an example, we've solved problems every day, right? We had to have it done by the end of the day if we were going to stay on track for 5 months. We had a great problem to have. We had a shift lock key, a caps lock key, and we had a caps lock key on the 128 where we didn't on the 64, where something called a phantom key problem. If you press 3 keys at once on an array, it will think a 4th key is pressed. So we had to find a way to have a caps lock and still be able to press multiple keys on the keyboard. So we wired it to the 8502. 4 of us jumped in Shiraz's old office. Shiraz is now gone. And we got to a whiteboard, didn't tell management because they'd want to show up and add their input. And we said, well, let's just hook it directly to the 8502. The problem we made that we didn't realize back then was, well, that meant the Z80 couldn't read it, right? So you win some, you lose some. But the thing was, we fixed that problem, just the core of us, 4 of us got in a room, fixed it, and walked out 10 minutes later. So we had a technique back then called splitting our lots, where we would do 3 layers and hold them off to the side and then shoot the chip 4, 5, 6, the upper 3 layers. And I'll talk about that in a little bit, but these are the layers of a chip, more or less. Bill, I'm thinking there should be buried contacts there. I'm thinking I'm missing a layer in there. So there's this thing called a back bias. So we got this 80-column chip called that's a TED chip. That's the wrong chip. So we had the 80-column chip, and we had they tried to slip in a change called back bias. It's meant to reduce the power consumption, but it's right before CES. The 80-column chip had lots of bugs. It got up to like Rev 9 before we could use it. And they tried to slip in this back bias ring, it's called. What it is a ring of poly that goes around the edge of the chip, and they would try and create a charge pump and make the substrate go negative voltage. Well, it slowed it down. Now signals, instead of traveling 5 volts, had to travel 7 volts. So suddenly, my 80-column chip looked like this. You can't see it. Well, congratulations, we couldn't either. We had an eddy prompt. The leftmost column disappeared on us. So the chip couldn't recover fast enough from the horizontal time, from the resweep time. And I realized, getting there? 15, I'm good. So the way I fixed it was I knew that the substrate was available on this little gold pad, and I soldered a wire from the ground to this little gold pad. Bill, you ever seen anybody do that? Solder to the substrate? That's the pin 1 indicator notch. I soldered a wire to it. Grounded out to substrate. And the 80-column chip designer, you thought I just drowned his kitten. He's like, you did what? I said, I made it work. He's like, you're grounding the substrate. I'm like, but it works. So basically, I shorted out everything he had just put in the chip just to get it working again. There's the CPM why it didn't work, and I'm not going to bore you with it. So meanwhile, I'd hired a third guy named Frank Pelea. Remember, now we're committed to having a Z80 in this thing, and it has to work, right? If it was just a cartridge, you could go, well, maybe not all the cartridges. Well, no, now it has to work. Look at all this junk we ended up putting in here, right? Well, the reason why it's jelly beans like this is for cost. A TTL package cost me, I want to say 2 pennies, 2 cents. It cost me about 1 penny to have it inserted. So this cost me a total of 4 cents. No, I'm sorry, 8 cents by the time it's inserted. We could have done what's called a PAL, but a PAL cost $1, then it cost $1 to program it. So this was us doing the down and dirty, cheapest we can. And Frank Pelea really came through. He figured out all this logic because the more we got into the Z80, the more we found things like we would get to a certain cycle and it wouldn't stop on a dime. It would do 1 more clock cycle. So Frank figured out a way to do all this, and all these cuts and jumpers to insert the parts of this, we did without interfering with our FCC submission. Meaning, we are allowed to have cuts and jumpers. We couldn't move a part, we couldn't add a chip, but we could add transistors and we could add wires. Oh, everybody, you guys know these stories, right? Anybody want to tell this story for me? My voice is going a little. You remember the Koala Paint story? So our manager of QA had stood on a chair at one point and said, it won't work. And then every problem that cropped up, he'd say, see, I told you so. And I thought it was a good idea to have a QA. We didn't have QA in engineering before, in R&D engineering. So lo and behold, one day my phone rings and the guy's like, they're on their way up. Okay, you gonna tell me more? Nope, they're on their way up. So the movie Dirty Harry was out back then, and in there, Dirty Harry had eaten a sandwich while calmly shooting these bank robbers, right? I liked that concept, and so I got a sandwich out. I'm in the hallway eating my sandwich when this rabble comes down the hallway, and they're holding a Koala Paint cartridge. And the head of QA, both QA guys are there. And instead of, oh no, we're going, I took the thing from him, and now he has to follow me. I'm eating my sandwich, holding the Koala Paint cartridge. I go into R&D lab and I plug it in, and we're told it's a complete crash, the program's a failure, C128 won't work. And what would happen is, let's see, this screen would come up, and then it would start to paint the characters, this red color. And these font, this is actually from the C64 font. Well, one of the things we had thought would be a good idea was, if you ever look at a Commodore 64, you notice how the font looks a little funny. The descenders, the J's and G's look a little silly. So we fixed them. We did things, we moved the dot on the I, we made the J's and G's a little better. Well, they used that same font and they made it bigger and they made this word Koala Paint, and then they paint the K red and then they paint the O red. And the problem was, when they got to the dot and the I, we had moved it. They missed the dot and the I, and it took 2 minutes for it to paint in this whole thing. It's not broken, it just missed the dot on the I. So what we found in that moment was to be Commodore 64 compatible, you couldn't even move the dot on the I in the font ROM. That was a eye-opening experience for us. We fixed it within an hour as I go. Basically, I grabbed a Commodore 64 ROM, had a tech solder it directly to it. We call this brick lane. And I had a signal that was high for 128 mode, low for 64. And we switched between these two ROMs. So again, fixed within an hour, crisis averted, but it turns out that we had to make the font ROM have a 64 mode and a 128 mode. All right, I'm going to try and wrap up quick here. One of the last things then was we slid in the Magic Voice cartridge, and lo and behold, it crashed. And they're using the control lines in a way where we're not used to using them. And the problem was that the 6502 would go to its reset vector, FFFC. And this cartridge would go, I'll take care of that. Well, wait a minute, you're a 64 cartridge. You know nothing about setting up the MMU and the C128. How can you take care of this? And we were stuck. Our own cartridge wouldn't work on the Commodore 128. So overnight, I invert the polarity of the Z80 enable signal. Now the Z80 wakes up first. Let's see if I have that screen. And the Z80 doesn't start at FFFC. The Z80 starts at 0. So the Z80 wakes up and he goes, is that cartridge out there? Oh, there it is. There it is. And he would set up the thing for C64 mode and then jump to it and the cartridge would take over. So suddenly the Z80, which I had put in there to solve a power supply problem and a cartridge problem, saved my life. It literally threw itself in front of the bus for us and took a hit. So every Commodore 128 boot first, and it 64 cartridge out there and sets up appropriately. All right, coming up on the last couple things here, and then I'll shut up. So this is a great story. We got one rev of the VIC chip, and it went backwards. And Dave Diorio spends the time in the chip lab probing it and looking through the microscope. Now, I take him out for beer that night, Michelob. And as he's sitting there, his brain developed the Polaroid pictures his eyes had taken while looking through the microscope. And he realized that chip fab had swapped in an old mask. Right? It wasn't his fault, basically. It was just a problem in the process. And it was the Michelob, I think, that helped him to see that. We had another problem. I used to fight hard to get 38911, that number, to appear. We got a rev, the second to last rev of the parts, and it would crash. You see this garbage on the screen? It would just blah on the screen. I don't know if you guys can see it or. But there was no way to capture this on an analyzer in real time. Our analyzers really were poor for back. They were great for back then. They're poor for now. Well, what I did is I took a light pin and I held it. I circled this on the screen and I held the light pin to it. And I triggered the analyzer whenever that @ symbol would appear. So it was like I was using the TV monitor itself as part of the logic analyzer process. And sure enough, I was able to catch a bad memory write cycle. And we traced it to this one little trace here was 1/8 of an inch too long. Again, fixed in hour or so. Y'all have heard the hole in the wall story, right? Yeah. Anybody want to hear it? Sure. All right. Getting near time here, Jeffy. 7 minutes. All right. I can do the hole in the wall in a minute. So I had my own room by this time where we did the C128, where I had my emulator and everything. Well, the security guards liked their jobs very much. They liked going around locking any door that had a door lock on it. Well, the problem with my lab was nobody had the key, so they would lock my door. I'd climb up over the ceiling, get that white stuff all over me, drop down, unlock the door, and I'd go on working. Put up a sign, a nice polite sign that said, "Please don't lock this door, there's no key for it." Next day, same thing happens. I get that white stuff all over me again. I'm a little terse now in the sign saying, look, don't lock the door, there's no key for it. On a Saturday, I show up to work. We all work 7 days a week. And then my door's locked again. They said I punched through the wall in one punch. It took 2 punches. I had to punch it once for the outside wall, once for the inside wall. And I reach through and I unlock the door and I go back to work, right? I put up a sign. Well, then the amazing thing is they locked the door again the next day. So I had to put up a sign that says, look, Frank, there's a fire trucking hole in the wall. You don't need to lock the door anymore. So this was an example of what we had to go through, you know, to get our jobs done. But we weren't going to let anything stop us. So that's the hole in the wall story. One last one. There's a couple more. Remember, there had not been a reset circuit on the 64. Well, when we added one to the 128, it didn't work right, not every time. And we ended up inserting, remember now, FCC is only a month away. We ended up inserting a gate. I put a gate here and made a latch with just 2 wires. And at that time, I gave myself the nickname Captain Klooge, because this is a real dirty fix. But it was another example of something we fixed in an hour. Then we had another problem. I mean, it just went on like this, you know, as we got to CES show. Remember this back bias ring that we talked about? I get a version of the PLAs come in, and they don't work at all. Well, I measured the resistance between the input terminals, and there's 200 ohms between each terminal. Bill will tell you that's the resistance of poly. They had gotten this back bias ring in the wrong place, and it literally shorted down these input pins. I could drive it really hard. I made a tower, and it would drive it, and the chip would get hot, but it would work, and we could prove it worked. But this was within a month of CES show, this happened. All right, we'll jump to the final guy. So meanwhile, the 80-column chip has given us lots of problems. It didn't work, and it didn't work because it had its own clock, and the guy didn't do something which is called synchronization. Synchronization is where it's like 2 different revolving doors. If you have the doors revolving at the same time, you can walk through one into the other. But if they're walking at different rates, and you're carrying a mountain of packages called the data, you walk into there and you hit this thing and you're out of step. Your packages may arrive and you didn't, or you arrive and your packages are stuck back in the revolving door. And so we had to synchronize it for the CES show. This is 2 weeks to the CES show. And we ended up phase locking the 80-column chip using this tower. This little tower cost $1,200, 1980 money back in the day. And we put this in, and it saved the CES show, quite literally. And so that was the phase lock loop tower. Finally, CES. We get there, and you'd think we're done, right? Silly. Does that look like the 80s or what? It's just even looking like awesome. It is. That's an awesome shot. Terry Ryan, the guy who did BASIC for millions of people, did that. By the way, Terry got in trouble for the way he did BASIC for millions of people. Terry Terry implemented do loop, loop while, the structured BASIC that's in the 128. I love that BASIC. Well, his boss told him that he had violated what he had been told to do. He's like, well, while it appears that what you did was correct, it nonetheless went against my orders, therefore you get a 3% raise. I mean, it's a Dilbert comic, right? So he got in trouble for implementing BASIC the way we did it. We get to CES, and the 80-column chip has this new problem. It's drippy. It looks almost like the Matrix. And we told Vaughn, what happened was Von Ertwein, the guy who had done CPM for us, hadn't been using the most recent CPM chip, or I'm sorry, 80-column chip. And he had been using one that he could cool with a buttercup out of his hot popcorn air popper. He would put an ice cube in it, set it on his chip, and it would keep it nice and cool while he wrote his code. And he was on Rev 4. Meanwhile, we're up to Rev 8. So we get there and we told him, hey, you need to do what's called a Texan write. That's where you write the same value twice. He ended up sitting in this chair here and using just a disk editor the night of CES show, and he rewrites the code. He can't add instructions. He can't change the number of instructions. All he can do is use a disk editor and edit the instructions and then recalculate the CRC for it. And each sector is backwards, and each sector is backwards on the whole thing. He did all of that by hand, and it worked. So here's this guy, I mean, true C-128 animals fashion, which was our nickname, by the way. This is us at CS show. We took things real seriously. Here's me about to pour a beer on a disk drive. Here's Greg Berlin holding a disk drive while somebody kicks it. Here we are stacking a beer. By the way, we drank Michelob out east and Coors out west, because back then you couldn't get a Coors east of the Mississippi. They're trying a disk drive and a beer on top of Dave Haney's head, and this is Fred Bowen, what I call the father of the C-128. I'm the mother of the C-128 because you had to come talk to the mother before you had to talk to dad, which was Fred Bowen. All right, after CES show, I'm almost done. We needed to finish the final rev of the PC board for FCC. Meanwhile, the bosses all took a trip to Italy, it was. And the boss they left in charge, this is right out of Dilbert, says, you know, I'm lowering the priority of the C-128. It's gone on for just far too long. So no C-128 work got done that week. I think I took a shower that week, you know, went home, took a bath. The bosses get back, and they go, you what? Huh? What happened while we were gone? So we worked 3 days straight through the weekend. I worked all 3 shifts, all 3 days, and I had an air mattress and my military sleeping bag in there. And it took us, almost 12 hours to route the last 5 signals on the C-128 board on these things. It was so full that we had to do that. So we call it the weekend of tears. And the guys that gave their lives, it actually says RIP, this is on every production board, rest in peace, Herd, Fish, Guay, Par. And those are the PC board designers that gave their life to be done in time for FCC submission. Y'all have heard the wire story. You know there's a wire on every C-128, right? I don't think I have time for that. I'm going to skip that. So finally, Easter comes early. The guys waited till there was, the ROM was set. I couldn't change it. Then they go, by the way, we put in an Easter egg. You what? Because I'd been the first guy to tell them, don't complain to me then when you don't have enough code, right? So their little gift to me, link arms don't make them. That's Terry Ryan, the guy that wrote BASIC. And you'll notice it says hardware instead of hardware. I just happen to have the one name that you could do that to. We get to the CES show, and it says compatible to, expandable to 512K. Well, my boss had decided to not make it expandable, and we find this out at CES. I remember, because we got back, and there was a dog and pony show, and the big boss, the CEO, asks my boss, where's the RAM expansion plug-in? And he said, in the back. He puffed on a cigar and said, in the back. Well, so was born the RAM expansion unit. And we caught it in time that we could include the basic commands for, this is done via DMA, direct memory access. So we thank goodness we had enough time that we were able to add the code for it, and that's why this was a thing. And so we showed at the Chicago CES show, we were able to show an animation. This was a cool animation, and this is like a 5-line basic program where he's just getting and putting whole images from this RAM disk. So we had I don't want to say bitchin', but we had a bitchin' RAM disk for the day. Post-CES, the LCD gets canned. If it were up to me, there shouldn't be a C-128. There should be an LCD machine. The C-128 was just a stopgap measure, meant to have something to show at CES show. It was meant to sell for a year. It went on to sell for many years, 6, 7, something like that. Sold upwards of 5 million units. But it should have been the LCD machine, right? Now, as it turned out, the 128 was cash we needed. That's over $1 billion. That's $1.5 billion in 1980 money, the revenue that we made. But it should have been the LCD machine. I'm still sad about that. Post me leaving, the C128D gets canned. This was my favorite machine. You don't find this. These are called the plastic versions. These did sell in Europe. There's a metal version I had nothing to do with. But, and they got rid of my fuse that I was on so much. So, and that brought us up to Act 3, the Amiga. So I've been Bil Herd. Thank you all for listening. I went fast. Oh, and real quick before I leave, I had a chance to get in the old MOS building, and Doug Crawford and I found these in the basement. Bill, remember when wafers were that size? This happened to be the 80-column chip, the bane of the C128. I found a wafer of it in the basement. So, by the way, there is a book that came out, if you haven't heard about it, and it's got actually all these stories in it. It's called, I had to look at the name, Back into the Storm.